together.
This is going to be a boring show, everyone. I'm sure of it. All right, as we wait for the cue from everyone out there, make sure we are live.
I gotta make sure my hands are
And if you are watching the stream, make sure turn it off so we don't have the volume from the stream going out there. Okay, everyone watching, we're going live in 3, 2. This is TWIS. This Week in Science, episode number 710, recorded on Wednesday, February 27th, 2019. Wherefore art thou, Planet 9? Hey, everyone, I'm Dr. Kiki, and tonight we will fill your head with possible planets, zebra camo, and yeast. But first,
disclaimer, disclaimer, disclaimer. Say you want to say something that sums up everything that is known about a subject. The easier a time you have doing so, the less we likely understand about the thing you're summing up. In fact, there are few things worth thinking about that can be summed up succinctly. There are just too many things that we do not understand well enough to say anything meaningful about them without leading us to more questions, which is fine. It's always been this way. It's a big, wonder-filled world out there. But there comes a time, from time to time, when humans attempt to make demands of the universe, to tell a story that sums it all up. A text, shall we say, that summarizes the universe into chapters and verse, as if to say, everything that is not understood by this time tomorrow does not exist. This occasional human tendency to end the pursuit of knowledge has come and gone and lingered lavishly throughout history. But there is one place where the pursuit of new knowledge never rests, where wondering humans never satisfactorily are silenced by answers, a place where the next question, and not the last conclusion, gets pulses pounding. And that place is right here on This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again to talk about so much science fun. Got stories. You know, we always have stories. I have stories about changing climate and making coal because we need more of that, right? What do you have for us, Justin?
I bring you CBD yeast and the most abundant, diverse biological place on planet Earth.
Most diverse. All right, I'm ready to dive in there. And Blair, what's in the animal corner?
Oh, you know, classic week. I just brought some zebra stripes and some gambling birds. So,
birds with a gambling problem. Mm-hmm. Yes, let's get in there. And we also have an interview tonight with some planet hunters. But before we dive into that interview, I'd like to remind you that if you haven't subscribed to This Week in Science, you can do so by going to TWIS.org. Lots of information there. You can also find us on all the places podcasts are found, YouTube and Facebook. Search for This Week in Science. Also, if you're in the Portland, Oregon area, we will be having a live show at the Alberta Rose Theater on April 3rd. You can find an announcement on our website. But now it is time for our interview. And I would love to introduce our guests tonight. Our guests tonight are Dr. Konstantin Batygin, an assistant professor of planetary science, and Van Nuys Page Scholar at the Division of Geological and Planetary Sciences at the California Institute of Technology. Also at the California Institute of Technology and in the same room with Dr. Batygin is Dr. Mike Brown. He's the Richard and Barbara Rosenberg Professor of Planetary Astronomy. With his Twitter handle at Pluto Killer, you may know him from the role he played in demoting Pluto's status as a planet and from his book where he titled it How I Killed Pluto and Why It Had It Coming. We are thrilled to have them on the show to discuss their latest set of papers, suggesting a path to discovering and bringing our solar system back to 9 planets. Welcome to the show.
It's great to be here.
Thank you. It's fun to be here.
Yeah, we are.
Now, is this some sort of court-ordered restitution that you're being forced to make?
So
for having killed one planet, you must find another to replace it.
So I will tell you a true story, but only one. The rest of them I'll just make up. But this one's true. My daughter, 5 years ago, which was a good year before we even started having an inkling that there was a Planet 9. My daughter, 5 years ago, would have been 8 years old, and she said to me, "Daddy, do you know how to get everyone to stop hating you?" And I was like, "Why, no, 8-year-old daughter? How will I get everyone to stop hating me?" And I was not knowing everyone hated me. She's like, "You need to find a new planet, and then they'll not hate you. And also, you should name it Pluto when you find it, because then Pluto's a planet again." So I was
Pluto
like,
Junior.
I will get right on that. And shockingly, except for the naming it Pluto part, we're well on our way. So maybe people will someday stop hating me.
I don't think so.
I have dreams.
So you've gotten into looking at these solar system objects, Kuiper belt objects, the Oort cloud, these outer solar system objects. You also look at planetary dynamics. But how did you both come to this place of going, there's something going on out there?
Well, look, I mean, this really started in 2014. I had just come back to Caltech, and Mike and I had worked previously, but when we kind of reconvened, we thought, okay, let's think about some of the interesting problems that are out there, and we were really inspired by work that one of actually Mike's former postdocs, I guess back from 2002 or so, and collaborators had done, where they had found this additional object whose orbit was unlike the typical Kuiper belt object, and we thought that's interesting. Let's look more deeply into what's going on. And really, it was actually on the first day of working together again on the outer solar system that we noticed that all of the orbits in the distant solar system, if you zoom out enough, they're all pointing in the same direction. They all lie in the same plane. They look like somebody has carefully corralled and arranged them. And that was really the first kind of staggering moment, where over that June 20th or so week of 2014, that we thought, wow, there's something remarkable going on in the outer solar system. And that's kind of how we started.
And one of the things we said, for 150 years, anytime anybody looks at the outer solar system and sees something slightly strange, the first thing they always say is, bet it's a planet, bet it's a new planet, bet there's a new planet out there. And we said to ourselves, like, we are not going to be those people. Those people are always wrong and always ridiculous, and we're not going to be. So we spent most of the first year trying to prove that it wasn't a planet.
Indeed. I mean, that was really we dedicated a ton of work to working out every single hypothesis that wasn't a planet. And I mean, I remember this well. We used to make fun of the planet hypothesis
we still
every day. Sure we did. But after you spend,
right, you would come in, and you'd be like, "Oh, I tried this and I tried this," and I'm like, "Oh, guess it's a planet."
But I mean, that's scientific inquiry, right? Disproving hypotheses. It's like, all right, let's tear it down. Let's disprove it. Let's get rid of all those other options.
People standing up saying, everybody for the past 150 years has been wrong, but we're actually right. But the thing is,
everyone on this freeway is driving the opposite way except for me. I'm going the right way.
Yeah, but it turns out it's true. Everyone for the last 150 years has been wrong.
Except
I think we're right.
Actually, what makes you different from what was it? There's Vulcan, Nemesis, there was Planet 10 before we were demoted back to only having 8 planets.
There was an X.
Planet X. Greek.
Yeah.
Anyway.
There are a lot of them. Yeah. So
yeah, I mean, look. So each one of these models. I'm glad you brought this up because this is something.
Yeah, it's actually a really good question.
This is something that gets glanced over a lot. Each of these proposals, right? Every time somebody comes up with a planet, really what they're saying is that there's some anomaly in the data, and there's some physics through which the planet explains this anomaly, right? Traditionally, right, over the last 150 years, what has been wrong has not really been the physics, it's been the anomaly, right? The data that anomaly would go. Vulcan is indeed the only example where physics was wrong.
So Vulcan, I'm gonna interrupt just because you brought up Vulcan. It's the greatest story, which is that Leverrier, who is the one who actually used physics to discover the existence of Neptune, super famous for doing that, and wanted to get even more famous. I mean, the man.
Because we need more planets.
The statue is in Paris. I mean, how much more famous do you need to be than to have your statue in Paris? But he was looking at the orbit of Mercury and realized that, like Uranus, which didn't quite follow the right path, Mercury didn't quite follow the right path. And he hypothesized that the reason is because there was a planet interior to Mercury, Vulcan, very hot. And it was a great analysis because his with the physics that he knew of that day, he was absolutely right. And when no one could find it, it was a big mystery. Mystery was resolved when Einstein showed that the reason that Mercury's orbit is a little bit wonky is because of general relativity that's changing around some. So the observations were good. The physics actually just wasn't quite there. But Konstantin is right. In every other case, someone thinks they see something, and the answer is, yeah, you didn't really see that, what you thought it was. Your data were just not quite as good as you wish it were.
And you know, in our case, in the case of Planet 9, we really did worry about this for a couple of years.
3 years.
And really, it was only, I think, you know, with the paper that you led back in January that that really kind of has the conclusive answer that there is a probability, there is a chance that all of this is wrong. Right? There's a chance that all of this is a false alarm, and it clocks in at about 0.2%.
Yeah, it's 2 in 1,000.
Which is still pretty significant.
Sure. If you want to make a bet, I'm happy to make a bet.
If you're one of those gambling birds, yeah, sure.
I mean, it's not 6 sigma or anything like that, but
Right.
No, I mean it's exactly what it sounds like. It's 1 in 500.
So yeah.
So from the data, how did you start looking at it and start figuring out, okay, what is this? What was the anomaly? What that created this probability cloud of?
So I'll tell you that the
Planet
early
9.
stuff, from when we started looking at it 4 years ago, I remember I walked into Konstantin's office and I'm like, this is weird. Again, my former postdoc, Chad Trujillo, had published this paper showing one particularly anomaly that didn't make any sense because there's no actual way to make it happen. So I brought it down to Konstantin. I was like, what do you think's going on here? I believe it, but it doesn't make any sense. He's like, well, the thing that was measured was called the argument of perihelion, of which we've had many arguments about perihelion since then, but this was the argument of perihelion. And he said, well, that makes no sense to cluster the argument of perihelion. Did you try adding that with the longitude of ascending node? I'm like, I'm sorry.
I don't.
Say
Say it again.
Why would I do that? And he's like, just do it. So I added those two together, plotted them, and they lined up beautifully. He's like, yeah, that's going on. I'm like, okay, what does that mean? And what it meant was what he said earlier, which is that the objects, they all go around the sun. If the sun's right here, they're going around the sun. They all have these very eccentric orbits going around the sun, and all of them go off in the same direction. They should be, like hands of a clock all going off in different directions. And they're not. They're all pointed in one way. And the only way that can happen is either dumb luck, and that's the 0.2%, 1 in 500, or something is making them do that. And that was the insight that Konstantin had, which is that, yeah, I know it can make something do that, although we tried really hard to think it wasn't a planet. Turns out only a planet can really make things all line up in those orbits like that.
And Kiki, to answer your question,
I answered her question.
To provide a good answer to your question, it was a long time. It took, I mean, the models that we built were imperfect, to say the least, at first. And we actually, for the first, as you remember, 3 or 4 months, we had developed a model where everything was off by 180 degrees, as we later realized. So it's one of these things where this wasn't a eureka moment, right? This wasn't something that kind of all fell together and suddenly we went, oh my God, that's it. It was like a series of eureka moments that all over a period of about a year built up to something that we both, I remember in kind of the fall of 2015, we kind of looked at each other and said, wow, this is actually there. This is actually a compelling theory.
Yeah,
right?
And neither one of us took it very seriously. I mean, it was serious science, but it was like, okay, it's easy to be shown a phenomenon and develop an explanation. Explaining is the easiest part of science, and the hardest part is predicting and getting it right. And so we had this explanation of why these orbits were like this, and we were both kind of like, yeah, but it's just like, no, neither one of us wanted to stand up from this explanation and say, oh, there's a planet, because that's, most people who've said that for 150 years have been wrong. Okay. When we finally made some things that we could predict and that we didn't know were going to happen, and then they happened, they were like, oh, there's really a planet out there.
Right.
That's when we suddenly, like, I think both of our jaws dropped and realized, oh, holy crap, this is actually real.
So why though a planet? Because if the outer orbits sort of lining up on a plane sounds to me like they're just getting dragged along by the sun, and the sun is pulling a trajectory that sort of throws them all into this orbit. Why is it required to have a planet?
Well, it's a great question. Yeah, it's a great question. The answer is, if there wasn't a planet, right, everything would be randomized, because Neptune and Uranus and Jupiter and Saturn have the effect of randomizing orbits. If you look at the Kuiper Belt, not in these very expansive orbits that we now understand are affected by Planet 9, but you look at kind of the more compact, more proximate part of the Kuiper Belt, just plot the orbits. It looks like there's no structure. It's very, very symmetric. And it's only when you go out to these very long period, really distant objects that you start to see all of them line up. What that's telling you is that you go far enough away from the gravitational influence of the canonical giant planets that you know of, and you start to see the effect of the planet that is effectively our solar system's dark matter, the planet that you don't yet see, right? And must it be a planet? Mathematically, no, but astrophysically, yes. Right? There's no astrophysically plausible scenario other than a planet that can have the same gravitational effect.
So let me actually answer Justin's question. Because couldn't it just be that the sun is moving along and, like, you're on a boat and you're hauling things behind it and they're trying to catch up? And the answer is no. Gravity doesn't work that way. Once the sun is moving along, everything is moving along with the sun, and the process that Konstantin talked about would be perfectly happy having the orbits going in this way. If the sun's moving this way or going this way, it doesn't matter. The sun's motion, everything that we see in the solar system is relative to the sun is essentially fixed, even if it's moving with respect to something else. So the sun's motion can't do anything. It really is something that has to be out there that's putting these things into its orbits.
And then the question is, why don't we see it? Do we anticipate a retrograde type of orbit where we just all of our telescopes are tracking the wrong direction?
So I mean, everybody pretty much acknowledges that this is a terrible time in our country's history, and it might be because Planet 9 is in retrograde. I think
I'm gonna start using that. Don't worry, guys. Just because Planet 9 is in retrograde.
But I mean, is it that it's going like a different direction than the rest of the planets? Like, why is it so difficult to track a location on this?
It's not because it's not anyhow more complicated per se, and it's mechanistically, it's not more complicated than finding a really dim Kuiper Belt object. The issue here is that there's only one Planet 9, okay, and there's a big sky, and Planet 9 is so dim. It is unbelievably dim. It is hard to convey.
I believe it.
You believe it?
I believe how dim it is.
Oh, you know.
So I have a question. So while we were getting ready for the show, you guys were running tests or data sets, right? To try to see if you could find Planet 9. So what does that mean? What does finding
it means that we might discover it before this show is over.
Yeah, we'll try. Let me start one right here. I don't think we have enough new data since we started. What that means is that we are looking for. We think we know enough about what Planet 9's orbit is like, that we know its path across the sky. And so what we need to find is any sort of data from any telescope in anywhere in the world that has covered the sky multiple times. And we can see Planet 9 will be here, and then maybe a month later it'll be here, and then it goes here, and then it goes here, and then it goes here. We need to find something that matches the orbit of Planet 9. So right now, I'm actually looking at data that were taken over the past 8 years from Haleakala on top of not Mauna Kea, on top of that other one, Maui. No, it's actually on Maui. Maui on Haleakala, telescope on top of Maui, which was just taking pictures of the sky. And I finally just got those data, and I'm just looking for dots of light that show up here, like 1 month here, next month here, next month here. The only problem is that there are about 10 million of them. And so I'm trying to find the one set that follows an orbit that makes sense. And so that's what it means when I'm sitting here right now, looking over here, continuing to run this data set to see if there's a new object that fits exactly where we're looking. And yeah, not yet.
You're checking this thing, I assume, more often than, say, a teenager checks their Facebook, Instagram.
Justin, Facebook.
They're on Snapchat.
Facebook, yeah, teenagers
I don't know what
Facebook anymore.
I don't pretend to know what the kids are doing now. But the kids that in my day didn't have any of it. So
yeah, that's true.
Yeah,
we don't check it as frequently because it takes days to weeks to run the full analysis. So I do check it once a day, because once a day there'll be a few new areas of the sky that it's looked through, and I'll look at them, and then I won't find anything, and then I'll get really depressed and get the Jack Daniels that's sitting here on my shelf.
From the chat room, we have Kevin Unique, who is asking about the idea that this object could not be a planet, but maybe is a sum of masses that are all very closely oriented together.
Yeah, that's a great question. That's actually been a model that we first considered. That was the first idea that we had. We abandoned it back in 2014, but it has come up both by Madigan and McCourt, and more recently by a group out of Cambridge and Beirut. Yeah, and so that idea mathematically, works out just fine. Why? Because Planet 9's gravitational potential, the average pull of Planet 9, can be imagined over a very long period of time, as if it's a ring of mass, right? So you can imagine smearing the mass of Planet 9 along its orbit and having this ring of material perturb the distant Kuiper belt. You'd get the same answer. Is that plausible astrophysically, right? Could such a ring actually exist? Almost certainly no.
Wait. You need an eccentric ring, and needs to be tilted with respect to the planet. It needs to have an orbit exactly like Planet 9. You can get an eccentric tilted ring. Do you know how you do it?
Put a ring on it.
With a planet. You have to have a planet.
Yeah, you have to.
So you don't need Planet 9, but you need a planet to make the ring that makes you not have Planet 9. So it's all.
So you need like what? Like an asteroid with a ring big enough to make up for, but then so I mean, then the thing is, like, you would have to backtrack and say, how long has this thing possibly existed in our solar system to not have formed a planet? And
that's definitely one angle, but there's another more pressing problem, which is that such a ring, right, would basically get messed up by passing stars, right? Planet 9 can have its orbit changed a little bit, and that's okay, right? In fact, Planet 9's weird orbit is probably weird in part because passing stars changed it a little bit in the past. A ring would really need to maintain coherence. I mean, you'd need to be pathological about sending all of those asteroids on trajectories that are copies of one another, right? That is just that gets into some solar system engineering, which I think is beyond the scope of what's possible.
So how weird is this orbit?
So the orbit of Planet 9, we think, is on the average distance is, we have two different opinions, mine's right, is the average distance is about, it's about 10 times the distance of Neptune. So it's 300, a little bit more than 300 astronomical units, where astronomical unit is the distance from the Earth to the Sun. Neptune's out at 30, Pluto is out at 40. We think Planet 9 is on average something like 310 astronomical units from the Sun. So it's really
more like 450.
He's wrong.
Yeah, he's wrong.
And it's,
do you include both of your ideas in the model that you've fed into the computer that's searching for?
We multiply them together and take the square root.
yeah.
Divide by 2/3 through.
I'm doing the searching, so I mostly only include my models.
I'm doing the actual theorizing, so I only worry about
yours. There we go.
I'm sensing an issue here.
Another interesting thing is that it's so the planet, to make those eccentric orbits for the objects in the Kuiper belt, the planet itself has to be on an eccentric orbit. So it's about 40% further on its most distance than it is on its closest. So it's probably at its furthest right now. So maybe at 360 AU, but it also has to be tilted by maybe 20 degrees compared to the planets in the solar system. So it has to be on a very specific orbit to cause the effects that we see. And if you wanted to have it be this ring of material, that ring has to be on exactly that same orbit. Otherwise, it wouldn't work. So how you would make a ring like that stays for 4 billion years is, I think it's aliens. It's really
why you would even bother arguing it at that point is
because it might be aliens.
So I have the really important question, and that is,
I'm not going to answer that question.
If you guys find this planet, I'm going to ask it
No.
anyway, and everyone can just guess. If you find this planet, who gets to name it?
We only say when. Okay, you're going to say who gets to name it.
When? Who gets to name it?
Yeah, I thought you were going to ask what we're going to name it.
No.
So in the solar system, the rules for naming are all controlled by the International Astronomical Union, which sounds like a pretty nefarious organization. And they have rules for...
It's the deep state.
Astronomical deep state.
They have rules for everything. They have rules for, so if you're a crater on Mercury, you have to be named after a poet. If you're a moon of Neptune, you have to be named after a Shakespearean character. I mean, they got names out the wazoo. The only thing that there's no rule for is what if it's a new planet? Because you're not supposed to find new planets.
It's just a Wild West free-for-all when it comes to naming planets.
So we ended up with potential Xena, right?
That's my fault. That was me.
Was that you?
That was actually me.
Oh, nice.
It's because I was a big Xena fan. And then when we found a moon of Xena,
it was your sidekick.
Such an obvious thing to name it Gabrielle. I mean, it was perfect. So when we find it, there are no rules, but we assume that as long as we don't propose to name it something ridiculous, that we
totally will.
Yeah, of course.
There's already a planet, Uranus. How can you?
Uranus.
I would think we would call it my anus. So I mean we will. And but we are as astronomers, I think as a bunch, tend to be very superstitious, and I actually have always thought it's because of the way that our observations are so affected by the weather. You have all these rain dances, you do everything else, and so one of my superstitions is if you come up with a name for it before you find it, you will not find it.
Right.
Oh my gosh! And what if somebody else finds it?
Oh
What if that? I just realized you've narrowed down bandwidths of where to look for it.
And not only have we done that, but we have actually been very open about it. We have published where we think it is. In fact, even today, our latest observations. And so it is entirely possible that based on the information we have made public, somebody else will go and find it. And I mean, it's not like I won't go home and have a lot to drink that night. But in the grand scheme of things, if somebody finds it before us, that means that they found it faster than we would have, and it got to be known faster. I would rather sort of Somebody finds it fast.
Magnanimous.
And
There
we
you go.
take longer to find it. It will be difficult. I'm not going to lie and say that I don't care. I care a lot.
I feel
course.
like you should be able to pre-name like if a planet was
But
found.
he said, no,
within
don't
Mercury.
rename it. Don't
I
rename
know,
it.
but what I'm saying is, if a planet had gotten found in the interior of Mercury, it would have been Vulcan, right? Like,
Yeah, you don't know.
there's
Do you know
no
where the name
room.
came from? Did Leverrier give it Vulcan?
Leverrier.
So here's the proof.
That's right.
Leverrier named it Vulcan before he find it. No.
You know what Leverrier didn't name is Neptune.
It's true.
Because after
There we go.
Neptune was discovered, Leverrier said, you know what we should name this bad boy? Leverrier. And I mean, not in so many words, but
No,
he kind of
actually,
insinuated. But look, I mean, at the end of the day, getting back to the question. So first of all, if somebody else finds it, we will drink enough to forget that they found it. Right back to square one.
Still be looking for it.
You know,
Years after.
Right back to the telescope.
and you know, it's so much better that somebody else finds it than us taking an additional 10 years to find it. Right.
So,
Yeah.
go ahead.
No.
Well,
Go.
I was just going to say, in terms of finding it and who finds it faster, I mean, finding planets at one point, it was just telescopes, right? These very simple pieces of glass put together. The telescopes have gotten more complex. Now we've got orbiting observatories that are giving us data in addition to these amazing ground-based observatories, and the speed of discovery can be so much faster. What do you think? What technologies are helping you do what you do now and could potentially help your competition find it more quickly?
There's really just two important things that are related that have happened in the last couple of years that are leading to the ability to find this thing quickly. And they're sort of simple to say and simple things that everybody can understand. So the idea to find Planet 9 is all you need to do is cover a huge swath of sky and look for something moving very slowly. So how do you cover a huge swath of sky? Well, you get a telescope, and at the back of your telescope is a digital camera. And when I first started looking for these things in the outer solar system, our digital cameras, this was like the early 2000s, our digital cameras were 400 by 600 pixels, like your handheld camera. And now the one that we're using has more than I can count. I don't know, 400,000 by 400,000. So it just means that every single time you take a picture with a telescope, you cover that much more sky. And without doing that, without that development in cameras and digital technology, you couldn't do it. And then one other thing that's not surprisingly related is the computers. So we no longer, when Clyde Tombaugh found Pluto, he found it by literally looking at the pictures and finding the one thing that was moving. Yeah. We don't do that anymore. The computer looks through everything for us first pass. And now because the cameras are so big, the data sets are so huge, we now have clusters of supercomputers running through all this, getting it done. Without those two things, we could have done the math to show that there's a planet, and we would have just
actually not even true.
I could have done the math. I couldn't have done the math. Right? It's a good point.
No, but like even the math, we kind of start off by doing kind of board calculations.
Oh well,
But to do the math, I mean, like the paper that we published today reports thousands of these large scale simulations that we couldn't have done 20 years ago. Right. So
or even 10.
Yeah, I think that's
maybe you could.
But I mean, look, at the end of the day, all of this stuff that we're doing now is only made possible by the advances in computation, by the advances in digital kind of optics.
Imagery,
And so absolutely we are driven, and all of this progress is driven by technological progress.
And yet still, some layman with a digital camera attached to a telescope with enough pterodactyl bytes of pixelations.
With enough pterodactyls, you could do anything.
could potentially do a time exposure and see one little line that's going off in a different direction if they happen to be pointed in the right direction.
You're absolutely right.
Get to name a planet. Right.
So, I mean, the probability is super small, but it's not zero. It might be like 0.2%, and those things never happen, right? We know that. At its brightest, Planet 9 could be bright enough to be seen by someone with a really huge backyard telescope. Not most amateurs would have
somebody with an 8-meter backyard telescope could legitimately find this thing.
It's not really a backyard telescope, but there are some of the super high-end amateurs have telescopes that I think are on the verge of being able to see it. But they only have these cameras with 400,000 by 400,000. That camera that we use, I think, is a $50 million camera.
At least. And then you have to turn it, so it's Japanese. So you have to. It's like
convert to yen.
Yeah, it's like 5 trillion.
5 trillion yen.
Yeah. So I mean, it's a super fancy camera. It actually has a lens on it, not the telescope, not the mirror on the telescope, but it has a lens to collect the light to go into the camera. The lens is taller than a human, this big around, and it's made by Canon. It's the largest lens. I think it's the largest lens in the world, and it was made by Canon especially for this Japanese telescope.
We take selfies with it all
and
the time.
We actually
all the time. It's like that's the pore right there on my left.
yeah. There's the hair on my on wart.
So you're talking about finding this dot of light out there. What does it look like? What do you think based on the data? I mean, how big is it? What would it be like based on our understanding of the solar system? And if this is a solar system object, is it rocky? Is it more gaseous? What would it be?
What a great question. And there is a simple...
And God, I wish I knew the answer.
That's right. Yeah, we have no idea. This is the most beautiful thing about...
Is this like the same as an exoplanet? It's like, it could be anything.
So
not
only is it kind of like an exoplanet, the most common type of exoplanet that we have found to date is 5 Earth masses. It's this missing link of planet formation that we don't have in the solar system.
Planet 9 is 6 Earth masses.
Whatever.
Don't you? I mean, you must have a range of masses for it to be, right?
6 plus or minus 1.
Yeah. So we know the mass
that's good.
pretty well. The mass we know well, but the size, the composition, all of these things we don't know at all.
It could be 6 Earth masses of hamburgers. I mean, we don't.
That would be odd.
We literally don't know.
Yeah. It could be.
But the number of masses, be it gassy or rocky. The number of masses itself.
So it's in that transitionary period, where transitionary range in mass, where you go from rocky things like the Earth at 1 Earth mass. Turns out Earth is 1 Earth mass, and on the next one over is Neptune, right? And Uranus and Neptune are the same. There's 17 Earth masses, and they have 10% of their mass in a hydrogen-helium envelope, right? So they have a substantial atmosphere. 5 falls right in the middle of that range, and we genuinely don't know. We assume that it has some atmosphere, mostly to make ourselves feel better, because then it's easier to find. It's brighter on the sky, but it could be just a barren, ice ball that's covered in dirty slush.
And hamburgers
on it, like Pluto.
Forget the hamburgers,
which might be more predictably, because if it has been affected by gravitation from other stars or something, or it's, you would think that atmosphere would be easier to strip off than in a rocky core would be something that would be easier to maintain in a long distance run. Right?
But these are things we will find out when we find Planet 9. I mean, really, these are some of the most interesting questions that we have about Planet 9, and we will get to study them if we are the first to find it.
And if we do find it,
when
within, like you've said in other interviews, within and also in the paper that you just released, within 10 years, you think it's going to happen? Hopefully very soon.
10 years.
You're okay with that?
10 years
when you
out than
find
a
it,
doomsday prediction. Doomsday predictions are at the most 5 years. Come on.
When we find it, what is it going to tell us about our solar system? I mean, isn't it possible that this object was a lost planet and like just a passersby that it got stuck and was like, I like this neighborhood?
Yeah, look, so
that's
right. And there's actually been already considerable amount of work done on the question of how do you form Planet 9? How do you get it to its weird orbit? As cool of a scenario as capture is, turns out it's something like 1 chance out of 10 trillion. Like
So
basically
you're
one
saying it's
out of
possible.
that's right. So you say
It's possible.
chance, right? Yeah, the most plausible scenario is that it formed together with the giant planets of the solar system, and then immediately upon formation was scattered out, and then was kind of perturbed by the passing stars, and kind of parked on this weird orbit. For now, all of that is essentially speculation. Once we know things about Planet 9, what does it look like? What does it have an atmosphere, or is it just a rock? What kind of orbit does it live on precisely? All of these things will not be answered immediately, but we can begin to kind of really quantitatively answer these questions.
And with 70 sextillion stars in the known universe and an average of 8 to 10 planets that we can see from the so thus far, probability, you're in a big pool of planets that were or solar systems that did capture or didn't capture too. So all of it is firmly on the table for this. So
yeah,
we really need to discover this.
Yeah, and not even knowing that it's like, not even having found it yet though, can't we model solar system dynamics to, I mean, we've discovered previously that there's been a lot of dynamic interplay between planets in our solar system, and then we have ideas that some planets have moved in and then back out again, and that they've changed their locations.
So we can definitely do these models, and in these same models about how the planets have moved around, there's a very natural place for Planet 9 to have come from, as Konstantin said, is that if it formed in that Uranus-Neptune region, it actually could have gotten thrown out of that Uranus-Neptune region during this whole process you're talking about. It makes a lot of sense. I actually, if I think where Planet 9 came from, that's the one that I think is probably true. But at the same time, as you said too, we don't know. When we find it, when we study it, we hope to be able to find things about it that will tell us what its nature is, where it came from, and how it fits into the general story of the formation and evolution of our solar system and other planetary systems around us.
And look, like, I work a lot on planet formation theory, and planet formation theory, I will be the first to tell you, has never made a successful prediction. Right? Planet formation theory has only been in this mode of always catching up to the observations. Right? Exoplanets get discovered. People say, "Oh my God! Turns out things move around, and we should have known that." Right? So we're always in this mode of kind of playing catch up. So I think the same thing will be true with Planet 9. When Planet 9 will finally present itself to us, we will go, "Oh, of course, there's some trivial mechanism that we should have known but missed." So that's where my bet is.
If you were to tell an 8-year-old, as your daughter possibly, or like my son, 8-year-old, who's telling me about the dynamics of the solar system, if you were to tell an 8-year-old how to become a planet hunter like yourselves, what would you tell them?
Actually, I have sort of an answer to that. Yeah. So you gotta, the key is to work with the best people, right? I think it doesn't matter so much what you do. It's kind of who you do it with. And I have been exceptionally lucky in my life and career, where I've had, exceptional mentors. One of them was Mike. Mike was one of my doctoral mentors. And I've just had, I've enjoyed this whole thing. Never felt like work, because I've been surrounded by fantastic people. If I was surrounded by crappy people, I would never be successful in any of this. And I think that's true generically, right? And it's subject independent. I got into this completely by accident. I met my undergrad advisor at a party, and we got to talking about chaos. And so that was that. I don't know. What about you?
Well, I would say 8-year-olds have fewer options to surround themselves with the best people, because they have to deal with their crappy
parents.
Parents first. As my 8-year-old told me, everybody hates me. And so, as an 8-year-old, I would say the other thing is to be curious, ask questions all the time, and don't take either, oh, that's too complicated, or you don't need to know the answer to that for an answer. Make people tell you the answer. Usually if someone says it's too complicated,
they don't understand.
It's because they don't know the answer.
Yeah.
And that's fine. When you realize they don't know the answer, go try to find out the answer. And then when you realize no one knows the answer, then you realize this is something you got to go find the answer to yourself.
I'd also love to know, I mean, both of you are fantastic communicators. I've been watching Konstantin, you've been tweeting about your papers, you've been communicating your work. Mike, you've written a book, you've blogged, you're talking with us on a podcast right now. Is this something that, did you do media training? Did you train up to learn how to do this? Or is this something that you just kind of, you are people who are good communicators?
No, I think it's just always been something I've thought is super important. We have this ridiculous privilege to get to go explore the solar system, and a lot of it is something that is funded by the public. A lot of what we do is not. I mean, the telescopes we use are not, but a lot of the stuff in general science is something. It's a bargain, I feel like, we make with the public, which is that we will let a few people go do these ridiculous things like go look for planets, and you tell us about it. And if you don't take your end of the bargain seriously, why do you even do it? Why would someone let you go off and find planets if you're not going to sit around and tell them about how cool it is? I mean, we could just wait and write the scientific paper and have somebody talk about the results, but I think people like to know what it's really like and like to hear about what's going on. So I think it's both an obligation and a privilege to get a chance to do these sorts of things.
Yeah, and I would say I 100% agree with everything Mike said.
Unless I say it's at 300 AU and you say it's at 500.
Well, you say it's 310, which is sort of, but
it's just a little details.
Yeah. I mean, so the other there's a selfish component to this, which I think is certainly there for me. When I go through the process of explaining it in non-jargon, non-equation, non-computer model terms, right? That forces me to conceptualize it in a way that's simpler, right? So I actually find that the communication is a useful thing to do, actually, to understand what you're talking about better, right? If you can't explain it, what that means is, it doesn't mean it's too complicated to explain. It means you don't understand it yourself, right? So I think it's just something that at this day and age, to some extent, more or less everybody should be doing.
We should all be talking about this stuff. Yeah.
It's cool.
It is cool. I mean, looking up at the sky, we all have that commonality, right? Being able to, we all have our feet planted on the ground, some of us less firmly than others. We all have,
is young indeed.
Yeah, but we all have this ability to look up and to look out and to discover. And like you said, Mike, be curious and ask these questions. And thank you both so much for sharing your story with us and for telling us about your science. And if people want to continue to follow this saga of Planet 9 as you dig into discovering its location, where it is, how can people follow you? Where can they find information?
So I mostly these days, if something new is going on, I'm tweeting about it, as you said, at Pluto Killer. Easy to remember.
It's very easy.
I also tweet about stuff. My handle is much more creative. It's at K Batygin, KBATYGIN.
It's complicated. Yeah. If you find me, you can see him because I follow him, so you can find it that way. It's a lot easier.
Yeah. But yeah, I kind of have been judgmental towards Twitter for a long time, but it's actually pretty cool. Yeah.
We sporadically update our Planet 9 blog at findplanet9.com, right?
.com. .biz.
No.
Findplanet9.com. All spelled out. Findplanet9.com. Did you post this latest?
Yeah, I actually had 3 posts on there that I posted yesterday.
More than all of last year combined. Sometimes I don't do very much, and we don't do very much because we're really super busy looking for this dumb thing.
Yeah.
So we don't always have time to post stuff and to do stuff, but
we do our best.
We do our best.
And we appreciate it so much. And if listeners out there are interested in the paper that you've got out, Konstantin does a great job of boiling it down over several tweets, or you can read the actual paper that's like 92 pages long.
It's pretty good. The first section is pretty good. Second section, I don't know. First half.
I wrote the first half.
You wrote the second half too.
I wrote the second half too.
All fantastic. Thank you both once again. I really, just really appreciate getting to meet you this
congratulations on
evening.
making it well past the 30-minute mark.
Yeah.
It always defines whether the interview was interesting or not. So.
All right, everyone, we are going to take a quick break. So stay tuned for more science from This Week in Science.
Peace out.
Coming up next.
Can't explain things you've heard more than intuition. A lot of reason shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see. The answers lie somewhere within this scatter plot of first assumptions were correct. Let's prove the rest. It's hot. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
Are you interested in seeing the TWIS team live in person? That's right. We can do that. You can do that. Join us April 3rd in Portland, Oregon at the Alberta Rose Theater for our live show. We will be broadcasting live at Science on Tap in Portland, Oregon, April 3rd. Show starts at 7, doors at 6. We have a special musical guest, the PDX Broadsides, who will be joining us with musical whimsy, nerdtacular fun. We hope that you will join us there. If you're also interested in helping to support TWIS and keeping us going as a listener-supported show, well, there are several ways that you can do that. The first way is to go over to twis.org. That is our website where you can find all things TWISy. And you can visit our Zazzle store. The Zazzle store is where we have all of our cool goodies with TWIS logos and art from Blair's Animal Corner calendars. There are ways that you can customize things as well. I saw somebody took a polo shirt and customized it really recently into a Ragland design, which was kind of cute. There are mugs and tote bags and all sorts of things. So go check out the Zazzle store. Parts of the proceeds go to support This Week in Science. And it is one of the ways that we support this show and keep ourselves running. Additionally, back at twis.org, you can click on the donate button. Click on the yellow donate button. It will take you to a PayPal interface where you can donate one time an amount of your choosing. You can also click on the Patreon link. The Patreon link at the top of the page at twis.org will take you to our Patreon community where you can click on the Become a Patron button. That's right. Become a patron and support us in a recurring way. Every month, you will be charged at the amount of your choosing. $1, $2, $3.14. That's right, Pi support. Or $10 per month if you would like to be thanked on air by name at the end of the show. I would love to do that. I would love to say thank you to you personally. Would love to say thank you, your name, at the end of the show. So I hope that you will check out Patreon and consider giving us a little bit of support. Also, one way that you can help support This Week in Science is sending people to the website where they can click on the subscribe button. Allows them to subscribe easily to YouTube, This Week in Science on iTunes, or on the Google Play podcast portal. You can also, if you go to twis.org for the first time, sign up for our newsletter. That's right, we will have a newsletter coming out on a regular basis, starting regularly very soon. So you just need to sign up for our newsletter to get regular updates about things going on in the world of TWIS. Everyone out there, thank you for supporting us. Thank you for being a part of the show. We really could not do this without you.
Can't explain the things you've heard with more than intuition. A lot of research shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't.
And we're back with more This Week in Science.
Yes, we are. And now it's time for our favorite part of the show. This week in What Has Science Done For Me? So good. The tonality there. Fabulous. This week's letter comes to us from Seth in St. Pete. Seth writes in and says, "Greetings, TWIS team from warm, sunny Florida." And I'm jealous of that because right now it's cold and snowy here, but I do like the snow. Anyhow, moving on. Seth says, "I was fortunate to learn of TWIS after hearing Kirsten plug it on another science show recently, and I must admit that I'm really digging your work. Thanks. That being said, I was saddened to listen to a recent episode in which there was no listener participation for the segment. So here's my first contribution. It's not groundbreaking or revolutionary, but it did ignite a supernova within my heart and mind. I am a proud science geek and father of 4 young sons who runs a high complex laboratory. To break up the monotony of my work week, I often go for walks through a nearby country park that meanders through several different Florida ecosystems. Even though I am currently trapped in the lab, I am still a field biologist at heart. So when I come across something interesting, various herpetiles, insects, shorebirds' feathers, seed pods, etc., I will often snap a photo or bring home a specimen to share with my boys. Such was the case yesterday, when I happened upon a large, perfectly intact horseshoe crab molt, Limulus polyphemus. Yeah, immediately I thought of my boys and wondered how they would react to my not uncommon but still strange find. When I arrived home from work, I let them know that I had a science surprise to show them after dinner. The boys were super excited. I thought they may even get a little scared when they saw what appeared to be a bizarre alien creature from some sci-fi movie, but I was pleasantly surprised to see their eyes light up with interest as I pulled the shell from its box. They couldn't wait to run their hands over its smooth surface and gently touch the many spines. They thought it was an animal and were a little sad that it had died, but I took the moment as an opportunity to give a quick lesson on some differences between how invertebrates with exoskeletons and vertebrates with endoskeletons, such as themselves, grow. When I explained how this was just a shedding and that as the horseshoe crab grows, it has to molt, I pointed out the open seam in the front of the carapace where the living animal had crawled its way out, and then explained how its skin would then harden to form a new shell. What happened next blew me away. When the mini lesson was over, my 4-year-old son, Emmett, looked up at me, his green eyes huge and full of wonder. Then with the biggest smile, he ran around the table, wrapped his arms around my legs, and said, "Thank you, Daddy." So what has science done for me lately? It rewarded me with a beautiful memory of sharing a love for science with my children, along with one very large, totally genuine, and unsolicited hug from my very special little man. I'm looking forward to many new episodes of TWIS and catching up on all those archived goodies. Thank you.
Awesome.
I know. I'm like, I'm gonna tear up here. I love stuff like that.
Oh my god, that's my everyday that I actually get to go out and teach. It doesn't happen every single time, but when somebody goes up to you for real in earnest and thanks you for teaching them something new,
I know.
oh my god. That's great. I love that.
Right. Yeah. Seth, thank you so much for sharing. We all appreciate this moment that you had with your son. It was a special moment for you and it's special for us too. Thank you for sharing. Everyone out there, if you haven't shared yet, come on, give us your special moment. Share, share, share. We love them. We want to hear from you. Whatever it is, what science has done for you lately. Send me an email at Kirsten, Kirsten, at thisweekinscience.com, or you can leave us a message on Facebook. That's right, This Week in Science on Facebook. Leave us a message. Let's get to some more science. Oh my goodness. Planet 9 is out of control. I love it. But in the meantime, we don't have another planet to go to. There are, so far 7 other planets in our solar system, but this is it. This is home, right? It is. So we need to figure out how it's all working and what's changing. So I'm going to start my news with, some good and some bad news, right? So,
okay.
Yes.
Right.
New study out.
Myself.
New study out February 25th in Nature Geoscience. Researchers from Caltech and from NASA have the Jet Propulsion Laboratory, and I believe also the Pacific Northwest National Laboratory have worked together on a study looking at what are known as marine stratus clouds, stratocumulus clouds to be specific. And these clouds, if you look at the reports that came out this week, the news that has come up is that these clouds, if global warming, climate change continues as it is, at a certain point, temperature or carbon dioxide levels will increase enough, temperature will increase enough that these clouds will disappear. And when they do disappear, at that point in time, we'll already have increased in global temperature by about 4 degrees Celsius. 4 degrees Kelvin. But the disappearance of the clouds will increase the surface temperatures of the Earth up to 8 Kelvin.
Now, wait a
Yowza.
second.
Which is hot. So here, no, go, okay.
Hold on just a darn second.
I know this is the bad news, but I'm going to come back with the good news. So go ahead.
Isn't all the evaporation of the ice caps in the ocean waters and the fresh waters going to lead to more cloud cover?
Yes and no. So it's different kinds of clouds. And what the researchers did is they created a very small scale model of a representative atmospheric section above a subtropical ocean. And they simulated the clouds. Clouds are one of the hard things in climate models. We have not been really good at simulating what's going on with the various layers within the clouds, mixing within those layers, and how the dynamics of it all works, especially over the open ocean, where you've got this evaporation from the water. As you heat, yes, more water vapor, more clouds, etc. And clouds have a twofold effect. One is that they're clouds, and by being white and fluffy, they're reflective, and some of them reflect light from and solar energy from the sun, which will help keep us cool. But they are also big and fluffy and absorb energy. And like Blair has said many times, there's like this greenhouse gas blanket that allows us to warm up. So we know from historical climate, around 50 million years ago during the Eocene, carbon dioxide, we know that carbon dioxide levels were pretty high, but we don't think they were as high as they would need to be which would be over like 4,000 parts per million. That's really high to allow enough temperature increase to do what happened, which is the Arctic was completely free of ice and nice and warm and temperate and had crocodiles in it, right? And so there's been a mismatch in our understanding of what was going on. And this modeling that they just did of these stratocumulus clouds, by discovering there's a particular point, 1,200 parts per million of carbon dioxide, where these stratocumulus clouds disappear. And so without further carbon dioxide increase, you have a higher temperature. There is a forcing that happens as a result. And so this is new information that can be put into our models so that we can make things more accurate. And there's a group of people called the Climate Modeling Alliance who are trying to build a new climate model that is even more accurate than what we have now by taking factors like this into account from real world Earth observations and simulations, and to actually represent these clouds and other small scale features that are not well represented in current models.
Gosh, 1,200 parts per million. That's a lot of business as usual.
It's a lot of business as usual, but it's estimated that we will get there within the next century.
Yeah, absolutely. But I think this is a great example of, hey, this is a really bad situation that we could get to, but it's avoidable still. Like there's still distance between that and where we are now. It's not an inevitability. There is an opportunity for us to steer away from that cliff.
And, yes, there is a possibility for us to steer away from it. Look, don't go that way.
Yeah,
let's not take that path. There's also, hey, this is a good example of how we can improve our models.
Yeah.
And the kind of work that still needs to be done to get us to an even more accurate place in what we're looking at. And yeah, I don't know. Hopefully we'll get there through new technologies like researchers just reported in a paper in which they have successfully, this is in Nature Communications, researchers from RMIT University in Melbourne, Australia, have taken carbon dioxide from the air and turned it into solid carbon. They are really they're like, hey, we came up with a new method looking at these other methods that have been done through the years, but we think we came up with a method that can work to basically take carbon dioxide out of the air and put it back down in the ground as coal.
How do we keep people from then using that coal again? Because that's what I'd be worried about, is like, hey, free coal.
Yeah, that's a big question. And, there's no way at this point to stop that, but we still have coal processing around the globe. And if we can improve the technologies that are able to capture the carbon dioxide released from coal technologies and recycle that carbon, that's fabulous. If we're able to do it in an efficient way, and this particular method uses a liquid metal catalyst based on gallium selenide, that works at room temperature, which is different from previous catalysts, which have to use very high temperatures. And so there's less energy input. And so when I say efficient, this is something that's at room temperature. There's no extra energy that has to be put into it. The second is that the way that this liquid metal catalyst works, a lot of other catalysts, they end up getting, they're solid and they end up getting buildup. So you turn carbon dioxide, the gas, into carbon again, but it builds up on the catalysts themselves, reducing the efficiency of the catalysts over time. And so you have to replace them or fix them, and they get gummed up over time. And so this new method, it just produces the flakes of carbon, and they flake out and they can be pressed. And turned into a lump of coal for your child's.
That's
what
pretty
if
good in
we
the short
just
term.
turned-
In the long term, those higher temperatures that you're talking about will be room temperature. So then,
Yeah, there you go.
It's all good.
I guess it depends on when it gets deployed.
I think it would be pretty cool if instead of turning it into coal, you made diamonds
I think
out
that
of
would
the
be
carbon dioxide.
Yes, I took this diamond from the air to give it to you.
This used to be harmful carbon dioxide, but now the precious jewel.
Yeah, and I mean one of the things they still have to dig into. I mean, of course, this is early stages. They're like, "Oh, we can do it in a laboratory." That's great. You created this tiny little piece of carbon, but one of the big things they're up against are the gigatons of carbon dioxide that are being released by industrial processes every year. We are releasing massive amounts. And so will this technology be yet another just drop in the bucket? It's not going to fix the problem, but it may be part of the solution. We'll see. Justin. Yeah. Justin, what you got?
I have no idea. Let me go and see. Oh, yeah. This is UC Berkeley synthetic biologists have been playing around with yeast. And they did a little bit of engineering, and they got yeast to produce THC and CBD, which is normally only found in cannabis. Feeding only on sugar. These yeast are, they say, an easy and cheap way to produce cannabinoids. Quotey voice for the consumer. The benefits are high quality, low cost CBD and THC. You're to get exactly what you want, says Jay Kiesling, UC Berkeley professor of chemical and biomolecular engineering, faculty science at Lawrence Berkeley National Laboratory. It is a safer, more environmentally friendly way to produce cannabinoids. So we talked about this, I think, a little bit in the past about all the benefits of, mostly we talked about CBD. And also the Farm Bill, which is going to allow huge swaths of land that were formerly being utilized for tobacco growth to grow industrial hemp. Part of that, though, is that it is it's not a clean extraction, in that it requires all the things that are required for agriculture, all the petrol fuel to run tractors and the fertilizers and the runoffs from that and all that other stuff. So to be able to do this basically in a manufacturing process, also the CBD at least would be federally legal. It would work its way through all of the laws. Basically, the laws aren't really that complicated. DEA laws regarding CBD only relate to the extraction from the cannabis plant. And you see nothing about the compound itself. So this would be completely legal for CBD. THC, however, they specifically outline in the DEA's laws, meaning it would be legal only in 11 states if you include the District of Columbia, which I am doing here. So medical research on more than 100 other chemical compounds in cannabis has also been very difficult, partly because of the legal situation, but also because the chemicals appear in very tiny quantities. There's not a lot of it there in any extraction. So to be able to sort of engineer the compounds that are going to be produced is going to allow these 100 other compounds to be studied much more efficiently than they ever would have been able to otherwise. This is quotey voice again of Jay Kiesling. The possibility of new therapies based on novel cannabinoids, the rare ones that are nearly impossible to get from the plant, or the unnatural ones, which are impossible to get from the plant, are now on the table. There's also this is not in the study. I also had previewed something that was talking about another cannabinoid receptor that was discovered in the human brain, and making it at least free that we now know of. So Kiesling's report results are available online in the journal Nature. It was on cannabinoids join many other chemicals and drugs that are now being produced in yeast, including human growth hormone, insulin, blood clotting factors, and recently, but not yet on the market, morphine and other opiates, which is also interesting because of the opiate crisis. CBD has been shown to be one of the things that's very effective in getting people off of opiates and morphine. So they kind of ran into a little bit of a problem, though, partway through this process. So doing this, they basically trick the yeast, engineer the yeast to produce something other than alcohol from sugar, and convert that sugar into chemicals that are then modified by adding enzymes to produce the products that they wanted, CBD, that the yeast then secretes into a solution and can be extracted. Researchers ended up inserting more than a dozen genes, which actually it's not a lot. Many of them copies of genes that were already used by the plant. However, the enzyme that performs a key chemical step in making CBGA, which is the precursor to both THC and CBD, they used that from the plant in the yeast, and it didn't work. We give up.
You couldn't just put it right in there and get it to go.
Quit. This is the thing. This is the gene that makes that creates the enzyme that does the conversion, and it didn't work. So they also then just looked for another enzyme that the plant produced that kind of did the same thing and stuck it in the yeast. Quotey voice of Kiesling. It worked like gangbusters. Once they had yeast producing the CBGA, they added another enzyme that converted that CBGA to THC, and then yet another enzyme if they wanted to create the pathway to CBDA. Through the products the yeast produced were predominantly THC and CBD. They could also separate other tiny molecules from that. And they had yet another enzyme that they utilized that could create CBDV and THCV, which are variants of the classic THCA and CBDA, which the effects of which aren't really that well known to science, but can be studied. And they could also put them in a state, the molecules that were being expressed by these yeast, so that they could be then further altered in a lab to produce the more unique cannabinoids that are produced by the planet, so that those can then be made in greater volume and can actually be studied, something that hasn't been previously possible. So Kiesling started a company, Demetrix, which I don't know why he named it that. Which
he has his reasons.
Yeah, but he's leasing the technology that he created from the University of California system.
Yeah,
because this is how it works.
That's how it works.
That's how you work. If you're a researcher and you develop something in the university system, it belongs to the university. But so he's leasing the thing that he invented from the university to start a private company that will be making probably boatloads of money. The economics
then
look
they will,
really
because
good.
then they'll sell it then probably to pharmaceutical companies or others for actual use in products after FDA approval.
Yeah, and so there are a lot of research potentials. There's actually this is CBD cannabinoids have the greatest potential for being utilized as concussion protocol, which means that, you know, when they go off to the sideline after a big head-to-head contact in a sports ball game, when they go into that tent to get looked over, they may be getting a CBD infusion to help protect the brain, because it's been shown to have restorative effects, regenerative effects, and protect it against inflammation and things like this.
Yeah.
We've already talked about, of course, the a lot of the other things that it does and over the years. But one of the interesting things here is there's also a big problem for doctors prescribing, even though it's FDA. There are medications based on CBD that have been FDA approved. The main methods of extraction from a plant come messy. They come in different dosages. They come with the different compounds. To be able to lab develop something that is the pure molecule of which it is that you are interested in using as a pharmaceutical or in your study is game changing.
Yep. The consistency is going to be huge. Yep. It'll make a huge difference. Yeah. Well, that's exciting. Yeah. Go yeast. They help us make all sorts of things. These little tiny creatures. Oh, speaking of creatures. I think I hear an animal call.
I'm texting during the show. Stop texting during the show, Blair. We can all see it.
It's your turn. It's time for Blair's Animal Corner.
With Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. And
what you got, Blair?
What do I have? I have an update on a story that I reported I think in 2012, in my very first year on this show, about zebra stripes. So we've talked a bunch on the show about why zebras have stripes, potential hypotheses. Then they were disproved. Then they were reproved again. And now we have a pretty good test of one of those hypotheses, probably the hypothesis that people enjoy the least because it's the least charismatic, but it sounds like the most likely now. And it is that it's all about deterring flies. Yes.
I missed that one completely. I didn't know that was.
Well, it was 7 years ago, so you probably just forgot.
This is an ongoing story. I love this one. Yes.
So back in 2012, when I reported on it, they just took painter trays and they painted them different patterns and different hues, and they found that flies didn't land on the black and white nearly as much, the black and white stripes, as others. So in this update from University of Bristol and UC Davis, they wanted to see experimentally how this worked. So they looked at actual video analysis, looking at approach speed and success in landing of horseflies on zebras and horses. So they found that stripes don't deter them from a distance. Both zebras and domestic horses experience the same rate of circling from flies, but it's all about approach speed and the ability to land. Horsefly, yeah, go ahead.
So the other hypothesis has been the one that jumps to my mind, at least, is that this is camouflage of the herd from lions. This is what protects them from. So what you're saying is zebra stripes, evolutionarily resource put in, more important to deter flies than lions.
So
how annoying does a fly have to be?
This is sticky. This is a really sticky scenario because these stripes are a type of disruptive coloration. And there's a lot of animals with stripes or spots or splotches. And it does have this inherent effect to break up the shape of a body. And makes it harder for predators to identify. So I think that
too. Like you look at a tiger and its stripes, is that camouflage, or do tigers also not like flies? I have all these questions.
Yeah, so there's kind of two different ways to attack this. So one is saying, okay, so they have stripes. This might help them with camouflage, but why is it black and white? Why are they so striped? There are other animals that only have stripes in certain places. Why are these animals covered in stripes? And why is it such a drastic black and white? There's nothing on the African savanna that's black and white. So why is it in this nature of disruptive coloration? So in this study, they found that the flies would just go right over the zebra stripes, or they'd bump right into the zebra. But this didn't happen with horses. And there were far fewer successful landings on those zebras in general. So their hypothesis is that the nature of the stripes reduces the ability to land on the zebra's coat because of disrupting visual systems, because the flies don't have a very good, they have very low resolution vision. So the idea is that as they fly in, it's harder for them to see kind of the depth perception side of things, to see exactly how far away they are until it's too late. And so they'll bump into them, or they'll overshoot and they'll fly over. The part that I love about this is they went, okay, but there's one thing that we're not testing here. And that is maybe horses just smell more delicious. So the second experiment was to observe horsefly behavior around horses that they had previously studied, but wearing zebra coats. So they put them in black coats, they put them in white coats, and they put them in zebra stripe coats. They call them livery if you're in the equestrian trade. So this excluded a difference in behavior or smell between horses and zebras. They did find a difference in behavior of how they acted around flies between horses and zebras. More on that in a second. But in this study where they just used horses, they found that when they wore the striped patterns, there was far fewer horsefly landings compared to when they wore single color coats. So first of all, this is interesting because there's a lot of money out there in taking care of horses. And if having racehorses wear zebra stripe coats, which might be a thing now, will reduce the amount of horsefly bites and aggravation to the horses, this is something that we might start to see popping up. But where this gets evolutionarily interesting is that they looked, again, I'm going to loop back around to this difference in behavior. Zebras had more preventative behaviors, such as running away and tail swishing, rather than horses. But horseflies that did successfully land on zebras spent less time there, probably because of that behavior. We know that in Africa, horseflies carry dangerous diseases that can actually kill them. But here in the Americas, that's a lot less the case. So if you look evolutionarily, it's not surprising that wild horses in the Americas don't have stripes and zebras do, because zebras had to do pretty much everything they could to avoid getting bit by horseflies and dying of disease.
And I like the fact that they did that livery study, because otherwise I would have been like, maybe the flies just have different preferences.
Yeah, absolutely. So this took it, even though it's just also really cool to see pictures of horses in zebra coats, and that might actually start happening now. I love that. But it's a really good example of going, okay, what are the different things that we could do to eliminate any confounding variables to make sure that this is why? It's not a coincidence. It's not that horseflies landed less on zebras and zebras are also striped. This is a correlation. No, they're trying to identify this causation. So we're getting closer. So in this already, in my awareness, 5 years of research just based on why did the zebra get its stripes, this is a hundreds or perhaps thousands of year old question. This is we're getting really close. I think it's very interesting, but I also think that zoos the world over are going to have to change their handbooks for sure.
Very possibly.
Yeah.
Something though that Schnago in the chat room is bringing up is the sample size, and this is a very low sample size study.
Yes.
So that is one aspect that needs to be considered. But additionally, they did many hours of observations, and so while there were few individual horses and zebras that were studied, the observations that they took were more numerous. But yes,
Yeah.
yet again, I mean, why not try? We have to get zebra coats on people, on dogs, on
Yeah.
horses, on just
Yeah.
try it on many different animals and see
Does
if
it
this
work on
kind of effect
mosquitoes?
still stands.
That's all I care about.
So I think also if you just wanted to look at a higher sample size of horses, if you wanted to give horse owners and horse caretakers zebra coats, and you said this might reduce their fly predatory behavior, I'm sure a lot of horse caretakers would absolutely take those in for free to record some information.
That's gonna be like the house. Like houses are gonna all look like zebras soon. Like if your front porch that you like to hang out with.
So that
paint
is
it zebra
something
stripes.
that has not been extrapolated out yet. We
No,
don't
it
know
hasn't,
if
but I am. Because I'm doing it
I'm
right
saying
now. Now it has.
experimentally, we have not looked at that. But I think
if you live in a place with a lot of flies, this might be something you should try at home.
I don't
Paint
know.
your porch like
This is
zebra
a
stripes.
weird question, because wouldn't you expect way more black and white animals if this were
would.
the case
No.
across
Yeah.
species?
No.
Yeah.
Not everybody figures out every evolutionary advantage.
The Earth is really old. There's
It's
certain things that, like flight.
Okay.
Flight works really well.
Yeah,
it's
why
popped
can't
up
we
a lot
fly?
of times.
Why can't we fly? Why don't we have gecko like clingy hand? Like, I mean, these are things.
I'm
that,
not saying it should happen everywhere. I'm saying it should happen more. How many black and white striped animals are there? There's not many.
And Justin, if you would like to increase the scientific understanding of this, I suggest you paint your school bus.
Oh, that's a really good idea. I
Black and
love
white
that.
stripes.
But you have to collect some data before you
Right.
paint it. That's really the key.
But again, I only care about mosquitoes. If it doesn't work on mosquitoes, I don't care.
Right. Yeah, I don't know. This has only been
Not
done
as
with
visually
horseflies.
oriented. Yeah.
Mhm. Or maybe they have better. Honestly, maybe mosquitoes have better resolution.
They actually
sight.
go after your CO2. They go after
That's part of
breath.
it. Yeah.
They
It's
use
not
breath.
so much vision
No.
with mosquitoes. Yeah.
So if that's the case, then it probably wouldn't work on mosquitoes because they're not gauging that. Who knows? I don't know.
We need to try it.
I don't know. I don't know that, but do you know what I do know?
I would like to know.
Birds are smart.
Wow.
Is this what?
This is in line with Kiki saying brains are amazing. And
Yeah.
calls
So
are off.
here's another
What are
story
you
about an
talking about?
African gray parrot doing something smart. The reason I brought this today, and it wasn't just another okay, yeah, we get it. African gray parrots have really good problem-solving techniques. We get it. This is a new cognitive task that I haven't seen specifically in a scientific paper that I think is the methodology is really interesting, which is why it caught my eye this week. So this was looking at first the classic 2-cup test. The classic 2-cup test is actually what I shared a GIF or a GIF, whatever your preference is, of this week on my social media. It was a dog where there were 2 cups and a treat was in 1 cup. And the other cup was empty and he had to pick a cup. So there's a hidden reward in one of 2 cups. They're shown 1 cup is empty. Those that successfully choose the other cup are thought to employ a process known as inference by exclusion. If it's not in this one, that means it's in that one. Is it in cup A or B? If it's not in A, it must be in B. So we know that young children are good at this, including infants as young as 17 months. And a lot of animals from a wide number of species, including parrots and dogs, understand this process. So this makes sense because in the wild, if you saw animals foraging in a certain area and you went to one field and there was nothing there, it's probably in that other field because there's food somewhere. I saw them around here. So it's a evolutionarily beneficial skill to have. But where this gets interesting is stepping it up to the 3 and 4 cup tasks to see really how well they understand this inference of exclusion. So for the 3 cup test, one reward is hidden in a single cup and another is placed in one of 2 additional cups to one side. So there's a divider in between 1 cup, and then 2 and 3 are on the other side of the divider. When faced with a choice, participants should pick the single cup as it is the only cup guaranteed to have a reward. So they're taught this, that the single cup always has a reward. The other 2, you have a 50-50 chance. This doesn't test inference by exclusion, but it does test understanding of possibility, of stakes. So it's what they consider a precursor to exclusion. What do I have the best chance of getting something good with? So tests previously have shown that until about 2.5 years old, human children fail at this task, but so do apes.
Oh, man.
A singular African gray named Griffin used in this experiment, sample size, right? 1 parrot, outperformed 5-year-old humans in this task.
Go, Griffin. Yes.
Then they stepped it up even further to the 4 cup test. Rewards are placed in 1 cup of each pair. So you have 2 pairs separated by a partition. 1 on each side has a treat. Then 1 cup in a pair is shown to be empty. So I'm going to flip, let's say, cup number 2.
So now you need to switch your first choice, the Monty Hall thing.
Yes, very similar. Although with the Monty Hall,
it's only 3.
It's a little bit more complicated. It takes a little bit more explaining. But this one is pretty simple. It's just if you showed an empty cup on this side, then they only have a 50-50 chance on cups 3 and 4, but you know to pick 1 because it is guaranteed to have something in it. 2.5-year-old human children, it says children in this study every single time, and I'm replacing it with human children, fail at this task as well. They don't understand, again, inference by exclusion. So the last wrinkle to this is that they wanted to make sure that he hadn't simply learned to choose whichever cup was next to the empty one. So they wanted to twist this test to force him to gamble. So for a small percentage of trials, they would put nothing on one side and show him an empty cup. So if he wanted a reward and understood the system, he couldn't go to the cup next to the empty one. He'd have to gamble on the 50-50 side. So they'd show they only put 1 treat in there. The researcher says, quote, and he hated it, but he did it on all the trials in the subset. The trio even developed a test in which he had the choice between the guaranteed small reward of a nut or, in a small percentage of trials, gambling gave him a bigger reward, his favorite treat, a Skittle. So then they wanted to make sure he wasn't avoiding the empty side completely. Again, he didn't always pick the cup that was next to the empty one. If he wanted the special Skittle, he had to gamble. He had to go to the 50-50 side, and he did this a good percentage. It wasn't 100%, but a very good percentage. What's really interesting is that if he lost the gamble, he wouldn't gamble the next time. He got burned. Yeah.
He's like, I'm not going to do that again. He's better than most people that way.
What's sort of interesting is
double down.
I wonder, though, if the young children, human children, as you described them,
yes, human
aren't
children,
doing a mimicking behavior. We have a 2-cup scenario, and you knock 1 over. So now it's your turn. What do you do? Well, that's only a 1-cup scenario over here. I'm not mimicking.
Right. Yeah.
Here's a 2-cup scenario. I'll knock 1 over because I'm mimicking what was done in the first example. And I sort of kind of wonder if there's if especially with the young children who aren't as goal oriented about the treat, if their focus is about mimicking the thing that they saw happen.
That's interesting.
And less about the ultimate result.
Yeah. Unfortunately, I don't know the specific mechanics of how it was done.
Yeah,
so I can't tell you specifically if
because that's
if it
a
was something
thing.
of that
That's
nature.
I mean, that's
Yeah.
a huge thing, especially in early child learning, is mimicking and mirroring things. Unless, I mean, young children, hopefully in this experiment, are well taken care of to the point where their immediate needs are always being met. To where that's not a really high priority, but the mimicking of a thing that they've seen or mirroring of it is a higher priority.
Yeah, so these birds socially, when they are growing up, when they're developing, it's in a social mimic setting. And so Irene Pepperberg, the researcher, her laboratory raises these African gray birds in a way that is very similar to how they would be reared in the wild, with when they're trying to teach them words and mental constructs that we use as humans. They do it in a model and response method where the researcher, the trainer will say a word, show a thing, say the word, show the thing, and then try and get a response out of the bird. And there's mimicking that is going on, definitely. And it's play and it's mimicking, and this is how the birds naturally learn their own bird language and their own bird behaviors in the wild, but it's being adapted to this laboratory situation. And so what the interesting thing here is that this is taking that mimicking behavior, but then taking it further to show the novel implementation of the behavior in a new setting. So it's a new problem. Take what you've been modeling and apply it. And that's with kids as well. Everything's mimic until there's some problem that needs to be solved and they have to apply their knowledge.
Right.
At a certain age.
I think what I find interesting about this in particular is I see a use of what I would consider logic by this bird, trying to figure out what his best chance for a reward is. That logic extends through values of rewards. And in this, it's all very anecdotal, I agree. But in this idea that when he gambled and lost, he was hesitant to gamble the next time, shows a really complex thought process going on in this bird's head. Because also it wasn't he never gambled again. It was just the next trial didn't gamble. And then if 10 trials later he was forced to gamble again, he might do it again. It was not an on-off switch. There was clearly something going on in his brain where he was weighing options.
Oh yeah, parrots are not degenerates, I think is what this is.
And what I think is interesting here also is the kind of like, we're trying to put a human intelligence age on an animal, and these birds do stay with their family units for a long time in the wild, up to like 2-3 years sometimes. I mean, they have a long youth. But at the same time, they grow up into adulthood a lot faster than human children. And so,
everything grows faster than human children.
Right? And so the comparison of like a 5-year-old kid and a 2.5-year-old bird and going, oh, this is amazing. It's like, well, the birds do have a different brain structure, but they have very, like, there are pathways that are very similar. And if the brain has developed to a more complex computational state faster, then it's going to be able to potentially do this.
I would even say more complex computational. I would put it as what are the immediate survival skills that are required, or what are the development the benchmarks that your brain is wired for at those points, and depending on your species. Like a deer must stand up and walk and run day one,
or within like an hour,
and run from a predator.
Humans don't really need to run to like this 4th grade PE class.
So I think from my experience working at zoos and aquariums and stuff like that, people get really focused on this this comparison of this bird or this animal is as smart as a blank-year-old human, because it's just something that they can grasp, that they can kind of apply to try to understand how smart an animal is, which is part of this long-standing narrative in Blair's Animal Corner that animals are smart, and we need to give up on this idea that intelligence is a uniquely human thing. But I think it's part of that gap bridging for the average human who doesn't hear this kind of stuff to start to understand, to start to accept this information that there are birds out there that probably could solve a puzzle faster than I could.
But as I always point out, there are no average humans of average intelligence who listen to this show. They are all above average intelligence humans.
Oh yeah. But yeah, so these kinds of numbers might be helpful to, I don't know, friends or family of TWIS listeners who are trying to communicate this to them later. But I think it's a good benchmark for somebody that is still starting out on the pathway to understanding that animals have complex intelligence and we just don't know how to test it, which I think is really what it's about, right?
Yeah. And what it's about, we have 10 minutes left in this show, so let's wrap it up. Blair, you have one more story?
Oh, I do. Just real quick. Some of you may have heard about this on the internets this week, so I will just say it briefly. You can find more information on our website with show notes and things. But a giant bee was found that was thought extinct. This was a bee in Indonesia. They have christened it the flying bulldog. It is the largest bee on the planet. It has not been found for 40 years. Whoa. And they found it.
How do you lose the biggest bee?
Well, there's lots of animals hiding there. The body length is 39 millimeters. That's about 4 centimeters. So that's about more than an inch. It's bigger than an inch long. So they say it's the size of your thumb. The wingspan is 63 millimeters. So that's 2 inches wide. That is a huge bee. So this is just a reminder that hiding in rainforests and far off places, or should I say far off to us Westerners, there's lots of animals and plants hiding, waiting for us to find them. And this is a great example of an animal that we need to preserve. Why we need to preserve these far off places, these rainforests, before it's too late for us to find things again. The flying bulldog lives.
I need that t-shirt. All right. I have a couple of quick stories. Have you ever wondered why some lemon fruits are sweeter than others? Some are sour, some are sweet. What's going on there?
Guessing sugar.
Yeah, well, no, it's not to do with sugar. It's not, you'd surprise. And it is related to the reason that petunias turn red.
Petunias turn red?
Yeah. So petunias, if they have more protons in them, more acid, more acidic, if you put petunias in more acidic soil, they turn red. Otherwise, they're blue. And it turns out that this acidity has a very similar root in citrus plants. Researchers at UC wrong place, not included in the work, at the University of, no, these are researchers who went to the University of California. Yes. Sorry.
But only for a day. They were just stopping by. Then they left and went back to the university that they're from, where the research was based in.
So these University of Amsterdam geneticists, there we go, from the University of Amsterdam, they got plants from the UC Riverside. They got genetic samples of sweet and sour lemons, oranges, pomelos, limes, etc., and looked at the DNA and gene activity, and they looked at a very specific proton pump that is involved in the cell walls of red petunias. Previously thought only to exist in the outer cell membrane, but they also looked at it in these citrus plants, and the genes coding for this proton pump are pretty much the same in the petunias and in the citrus. And if the gene is turned off, there's less proton pump, which means less protons going into little storage vacuoles in the cells, means less acid, means a sweeter flavor or a bluer flower. Similarly, in the petunias. Similarly, in some of these citrus fruits, they can have if they have more of the gene and they're more sour, then the flowers can tend to be more purpley, and because they're incorporating a little bit more of this red pigment that has to do with the acid as well. So red flowers, citrus fruits, proton pump, and the same gene. That's
Just a quick announcement. Nobody take the purple petunias. There's been some reports of bad purple petunias going around. Just want everybody to be safe, have a good time.
Be a blue or a red petunia. Oh, and additionally, if you're keeping track of the private space mission, the Israeli mission to the moon, they're sending a lander to the moon. SpaceX helped to launch it. It was a great launch. It's on its way. It's kind of complicated, doing a bunch of orbits around the Earth, and then it's going to get into the right orbit to be able to get caught in the moon's gravitational field, do a bunch of orbits around the moon, and then land. Well, it was doing some of those complicated orbital maneuvers, and it just restarted. And they don't know why, and they don't know what happened, but they're trying to make sure they can still get to the moon.
Man, that's why you don't hot dog in space.
It's one of those unexpected updates when you're like, okay, I got a lot to do today, and your computer tells you, no, you're going to shut down, you're going to reboot, and then I'm going to spend a lot of time screwing with your settings that you had.
Let's got to reset all the settings, get back on track. Are we still on track to find the moon? What's happening? We'll see. We will see. We want this. It would be cool to have the first private mission to the moon. Make it there. Love to see it. Justin, you have a last story?
I have representatives from almost half of all the known groups of microorganisms living on Earth, including dozens and dozens of previously uncultivated archaea and bacterial lineages, have been discovered living in a single sapphire blue hot spring, 8,600 feet above sea level, 10 miles into the backcountry on the edge of a caldera in Yellowstone National Park.
Woohoo.
It's a kind of a unique environment. It's a pool where volcanic gases rise through the spring to mix with snowmelt and rainwater. This phenomenon is allowing for exceptionally high levels of diversity, says Dan Coleman, assistant research professor at the Department of Microbiology at Montana State University. Coleman found more microbial biodiversity in a thumbnail-sized sample than is present if one were to combine all of the animal and plant biodiversity in Yellowstone Park.
Whoa.
Some of the some were bacteria, other were archaea, two of the three main domains of life, and fewer than half of them had been detected before in hydrothermal systems. So some, it says here, may even be modern relatives of ancient microbes, potentially offering lessons about life on early Earth and the potential for life on other planets. Though, to be fair, we are all modern relatives of ancient microbes. You guys, Quite
I'm a very major general animal and mineral. I can't remember this song.
Quotey voice, we think that this work has some pretty broad implications that stretch across several disciplines, says Coleman, who's the lead author of this paper. And the spring is known as Smoke Jumper 3, which he refers to as SJ3. Co-authors are Associate Professor Eric Boyd and doctoral student Melody Lindsay. A quotey voice of Boyd, I believe, this time. A lot of people are interested in discovering diversity. That's the end goal. That's admirable, says Boyd admirably. What Dan wanted to know is why. Why do we have so much diversity, and why are some springs more diverse than others? There's 14,000 springs in Yellowstone. Most of them contain like 2 colonizations. For this one to encompass half of all known microbial life on planet Earth.
Amazing. What happened?
Just insane.
Yeah.
So Coleman attributes that diversity to the unique geochemistry of Smoke Jumper Geyser Basin. So as opposed to a lot of other factors that people might have previously thought to look in a place, one of the things that gave them the clue when they first sampled just doing pH samples of springs, this one was unique from the rest. And that told them, hey, there's something sort of interesting going on here. He said Smoke Jumper 3 Pool is about the most perfect place to begin to understand geological processes that lend themselves to life. So we show, quotey voice, we show that it is due to geographic location, and not to mention that it is atop one of the world's largest active volcanoes. SJ3 is located at high elevation on the continental divide, features that prevent deep hydrothermal water aquifers from reaching this area. Coleman said SJ3 and other similar springs are fed by high volumes of volcanic gases that are generated by boiling of hydrothermal waters. And as those rise towards the surface, these gases can mix with near surface waters. And so they're getting what's very interesting and does have the implications of early life on Earth and life on other planets is these he notes that I'll quote him here. He noted that the volcanic gas that ends up is very different from gases that are present in our atmosphere in that they lack oxygen. So while we always are looking for those oxygen-rich planets to discover life on exoplanets, the really amazing thing about the gases that are infusing this pool is that they lack oxygen. This is an oxygen-free environment for the most part. That these are as a
and it's hugely biodiverse. It's great.
Yeah.
Yep.
So, and we know that our planet started pre-oxygenation with life.
Right.
And so to see an example currently on the planet with huge biodiversity and no oxygen
and it's not deep under the water. It's not a black smoker under the water. It's
the surface at a high
surface.
altitude.
It's great.
It says this is some more quotey voice from Boyd.
More quoties.
Just looking at the hot springs doesn't necessarily tell you how biodiverse it is, but as soon as we measured the pH of the spring, made our other measurements, we knew we were sampling a unique spring. Moreover, many of the lineages that we detected have recently garnered significant attention because their potential to inform on the evolution of methanogenesis, the biological creation of methane. In addition, previously unknown types of methanogens and deep branching microbial lineages associated with subsurface environments, underground environments, and many other enigmatic lineages, Coleman says, it is likely that additional studies of such systems could have the intriguing organisms will yield additional important insights into microbial ecology and will shed new light into their role in the evolution of biogeochemical processes. So this is, the old school view was life started in a primordial pool of gooey. This is maybe a living example
of that primordial pool.
Yeah, of the best example of a medium and a scenario for which life to exist and to flourish and to be diverse. So yeah, tremendous find. And it's in a national park.
Great reason for us to keep those national parks.
Yeah.
Maintained.
Yeah, imagine if that was a parking lot.
That's right.
I mean,
so
easily.
Very easily, but we don't have to imagine that right now. We've had a wonderful couple of hours of science, and we have come to the end of our show. So I want to say thank you to you for listening, for being a part of all of this. Thank you to Fada for helping with show notes and social media. And thank you to Identity 4 for helping to record the show. Thank you to Gord McLeod, Ben Rothig for helping out in the chat room, keeping everything hunky-dory over there. And I would also like to say thank you to our Patreon sponsors. Thank you to Paul Disney, Richard Onemus, Ed Dyer, Stu Pollock, Philip Shane, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Steve DeVell, Alex Wilson, Tony Steele, Craig Landon, Mark Massaros, Jack Matthew Litwin, Jason Roberts, Bill K, Bob Calder, Time Jumper 319, Eric Knapp, Richard, Brian Condren, Dave Neighbor, Aiden Jeff, Seth O'Gradney, Stephen Alberon, John Ratnaswamy, Dave Friedel, Daryl Myshak, Andrew Swanson, Paul Ronovich, Corinne Benton, Sue Doster, Dave Wilkinson, Ben Bignell, Richard Porter, Noodles, Kevin Reardon, Christoph Zuknurek, Ashish Pants, Ulysses Adkins, Sarah Chavis, Artyom Rukrimus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazewski, Jim Chapeau, Greg Riley, Sean Lamb, Ben Rothig, Steve Leisman, Kurt Larson, Rudy Garcia, Marjorie, Gary S., Robert, Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, and E.O. Thank you for all of your support on Patreon. And on next week's show, we will be joined by a microbiologist from UC Davis to talk about microbiology in the oceans. It's going to be so much fun. The show, you can find us as always Wednesday evening, 8 p.m. Pacific time at twis.org/live. But if you can't make it, don't worry. We are also on the YouTube, and our shows are archived on our YouTube channel.
Yes, thank you for enjoying the show. TWIS is also available as a podcast. If you want to find the show, you can Google us in your iTunes directory. Or if you have a mobile type device, you can simply look for TWIS, the number 4 droid, in the Android marketplace, or This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, including pictures of the flying bulldog, show notes will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts or other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line. Otherwise, your email, along with lots and lots and lots of others, will get spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover, address a suggestion for an interview, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from this show, remember,
it's all in your head. Oops, wrong clicker.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma. Got the eye. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
And we have come to the after show. After show, after show, after show. We're gonna show.
Hey, Kiki,
what?
guess who bought that Ragland shirt you were talking about?
Is that you?
Yeah, it was me. I wanted something to wear in Portland.
Oh, that'll be
And I was
good.
like, I know what to do.
That's a great idea.
Yeah.
It's a great idea. I
Mhm,
should do
mhm,
something like that too. I want a cute twist shirt to
mhm.
wear.
That's why I did it.
I could do something like that.
Yeah, you can put it on all sorts of fun stuff. That's what's so cool about it. And I was like, this will look great with a friggin' suit jacket. Friggin' suit jacket.
Friggin' suit jacket and a
Friggin'
beer.
suit jacket. Oops. The show's over. Listen.
You didn't say a bad word.
I have been on the internet on this webcam for now 8 hours today.
That's a long
Nope.
time.
9 hours today. I think I've reached my limit of being able to censor myself, and
You're a webfessional.
I just
Let's see. Identity 4 wanted redo intro bit up until the disclaimer. So just to make sure you got the disclaimer, Identity. You got the disclaimer. All it's just me. I'm just clarifying. No, I don't. You have it. Okay, so then I will go. I will record now. Beginning in 3, 2. This is TWIS. This Week in Science, episode number 710, recorded on Wednesday, February 27th, 2019. Wherefore art thou, Planet 9? Hey everyone, I'm Dr. Kiki, and tonight we will fill your head with possible planets, zebra camo, and yeast. But first. Bloop.
disclaimer.
So much energy on there. Okay. What did I do? Oh, Blair, newsletter.
Yeah.
I know we all have like the calendar and all that kind of stuff, but I wrote a list. I wrote it down, and I have to get it off of one computer and put it into the email. But wrote down a list, basically went through and were like, these are ideas for newsletters throughout the year.
Great.
Not that we have to use those things, but if we need a writing prompt, it's right there for us.
Shall we make a Google sheet like show notes so that we can fill it up with whatever we like and I can plop it from there into a newsletter?
I need a new segment on the show.
What?
I need a new segment for the show.
Why?
The segment is questions I wish I'd asked when our guest was here. One question is from last week's interview, when we were talking a lot about redshift.
Yeah.
Is why are we talking about an expanding universe? Because space-time is the same thing. Why aren't we talking about a slowing time universe? Like if space-time is indistinguishable, why can't we just be saying, no, things are getting further away. Everything's just getting slower.
Mm-hmm.
Right? Like, that's a great question. And I would love to then, in this segment on, having reconnected with the guest and asked the question I would have asked tonight, which I didn't occur to me till after the interview, was, wait a second. If somebody gets to name a planet, do they also then get to dictate how the naming of all the craters and the mountains are? Like, if I discovered Planet 9, I called it Planet Tom Waits, do I get to call the peak, the big mountain, Step Right Up? But that crater, I get to call Fumbling with the Blues, and then yeah, like another. But and the satellite is Swordfish Trombone, right? Like we get. Like, do you also then get to dictate all of the other discoveries, the micro discoveries that come after?
You know what's helpful for that, Justin? Twitter.
That's right.
No, I know. This is Twitter. Probably where it takes place, but
you could tweet right to them, and it would actually be a helpful thing to tweet like, "Thanks for coming on @TWIS Science?" Question. And they would respond, and our listeners would be part of that conversation because you tagged TWIS in the conversation. It'd be a really cool thing.
Yeah, but I also don't have a lot of follow through capability with things.
Yes, well, true. Justin, when you called me out for texting, I was trying to write a tweet, so that's exactly what I was doing. But I stopped halfway through because you friggin' called on me like a kid in class.
This show has video, and we're doing a show, and you're like looking down at, obviously, like, okay, if you think that
it was right before your segment,
texting and driving, everybody around you knows you're texting and driving.
Ready to go.
It's very obvious.
Oh boy.
I tweet, I text, I do.
Yeah, I'm just saying, like, I was still paying attention.
Oh yeah, I'm sure you were listening on some level.
We're multitasking. We're writing in the chat room. We're looking at I was reading your article right before that too. Like
Is that cool?
It's very interesting. I'm 100% sure there will be weed bread, but it wouldn't be weed bread. It would be CBD bread.
Oh no, you're talking about that article.
Yeah,
I was talking about the one that I sent you about the jumping.
Oh
spider.
yes, I saw that one too. It was a little
the
too
new
close
blue
to the
spider.
Show, but I think I'll try to bring it next week. Yeah.
Do you understand that I got the CBD article sent to me 10 minutes before airtime?
Yes. Do you understand
I had a whole other story I was going to do in 10 minutes before air? Somebody sent me that, and I went, "Oh my gosh, I have to do that show."
So we just have very different work styles. See, I spend Tuesday nights, and I spend between 1 and 4 hours looking through news articles, writing them, writing notes, putting them in the show notes, and then I read them again before the show and highlight them.
So what was interesting about this one, and we should probably do this in the after show, is that I pitched the idea of doing this somewhere.
What?
I pitched the idea of doing what they did in that study somewhere. which is why somebody, as soon as it came out, as soon as they saw it, they sent it to me.
Now, are you talking about the CBD bread or are you talking about the spiders?
CBD yeast.
Kiki, are those eyeballs or breasts on that banana?
I like to think
And by the way, what is the difference?
What is the difference?
My favorite, one of my favorite Saturday Night Live things. These alien women from another planet land on Earth, and they have eyes in their breasts, and it's because after many millennia of men just staring at our breasts, we've evolved to put our eyes there so we could maintain eye contact.
Oh my god! What is that? Is it
a buckethead zombie?
Oh, it's a zombie. Oh, I see it. Is his skin just like
it's gray?
It's gray,
dark gray. You know, because he's a zombie.
Yeah.
He's a bucket. This is from
necrotized,
Zombies, right?
Yes, this is a banana, and this is a zombie.
Oh, so it's a children's game. So it's definitely eyeballs. I get it.
No, children don't play that game. 40-year-old men play this game.
Oh, interesting.
Yeah, this is actually the demographic.
Oh, I don't even know.
The demographic of video games is very similar to the demographic of TWIS. It's very much the same crowd.
All of the people. Silly. Yeah. What was I gonna say about?
You didn't say, so we can't give you a clue. If you would say what you're gonna say, just blurt it out before you thought about it. We would be able to route you back to the thing you were gonna say. But because you hesitated and didn't spit it, wanted to think about it a little bit more before you said something, we have no idea what it was going to be, and therefore cannot give you a clue or navigate you back.
Well, we were talking
about
the
my new segment for the show.
What?
My new segment of the show, things I can't remember that I wanted to say.
Oh, okay. Yeah.
It'll be really boring because I'll be like,
I don't know. It was the thing.
Can I tell you guys something fun?
No, we're gonna talk about the newsletter. But yes.
I had a really obscure dream in which there was this amazing thing in my dream that I wanted to share with everyone. So in my dream, I reached into my pocket and I took out my phone and I took a picture of it so that when I woke up, I could show people. Which made perfect sense.
Yep.
In the dreamscape that as long as I can get to my phone, which is a real thing in my dream, even the technology functions the same way it does in the outside world, I could take a picture within my dream of this amazing thing I'm witnessing, and then I could share it with people when I woke up. And I was very disappointed when I woke up and I reached for my phone and I realized it's not going to be there. And I still looked.
Yeah.
And it wasn't there.
You still looked. That's funny.
I still looked. That was the part that was crazy, is that I still looked. But
my husband's on waking up and like picking his phone up and using it immediately upon waking. And it's really weird because last night he wakes up all of a sudden and he puts the flashlight on in our room.
Oh.
And I looked at him. I'm like, what happened? What's going on? And he looks at me. He's all bleary with sleep. And he says, do you smell smoke?
Oh my God.
But yeah, maybe there's a thing like the phone is transcending.
No, everything's fine.
The phone is becoming a subconscious object because we so interact with it on so many levels that it makes sense to us that it could translate between the worlds of the conscious and the subconscious. Like it's a permanent object in both. It's an appendage of the mind that should exist both in our subconscious and our conscious waking worlds. Therefore, it makes perfect sense that in my dream state, it made sense that I could take a picture of a dream and translate it to the other part of my brain in the outside world. And my outside world brain also thought, hey, there's a chance that this translates.
The thing that
Identity
I do.
4's dream. Identity 4 had a dream last week that he ordered a glass of banana wine at a bar. It cost $28.50.
Oh, American dollars?
Didn't taste good.
I'm not surprised. What I do all the time, it's very frustrating, is I and I'm not exactly sure if I'm dreaming that I look at my phone to look at the time, or if I actually pick up my phone and look at the time, but my brain just doesn't process it right. And I think I'm really late. And I will get to the point of even like trying to like slap my face to wake myself up, or like I will fully turn on the light to be like, come on, wake up. It's time to go to work. You're running late. And then I'll finally wake up enough to pick up my phone and look again. And I'll be like, crap, it's 3 a.m.
Yeah. Also, I as much as I don't approve of psychics having any merit or weight within society, I am on a massive number of occasions psychic by about 10 to 15 seconds, which is I'll wake up and I'll look at my phone right before the alarm goes off.
You're not psychic. You're just well trained.
No. It's psychic. It's psychic ability, but not the kind that lets you tell like the useful future. It's just the psychic that allows you to have to wake up and wait 15 seconds to hit the snooze button. Because that's the first thing I do. Like my first alarm is a snooze alarm.
This is something my mom has been able to do my entire life. Whether she wakes up at 5:30 or 7 or 9, she is able to train herself and can wake up 2 minutes before her alarm.
Yeah.
Yeah, it's pretty easy to do. Most people can do it, but I think the thing that's really interesting is but the thing about it, I think, is that we are so tied to time and like Blair, you were going to say circadian rhythms, and we're so tied to it that there's a part of our brain, even when we're sleeping, that is aware of how many hours have passed, which is fascinating.
Yeah.
I think that's really cool. Yeah.
And part of my brain is also aware of how many hours have passed since we started the show, which leads me to suggest that it's perhaps time to say goodnight, Blair.
Okay. Good night, Blair. Say goodnight,
Justin.
Justin.
Did we finish talking about the newsletter?
No, we didn't.
Good night,
we
Justin.
didn't at all.
Wait, there's a newsletter?
Oh my God. Yeah, I also was going to rant about daylight savings time, but you cut me off. Because my body,
I'm done now.
It takes the whole like 6 months for my body to get used to the new time. And I get to a point where I'm really good. Yeah. And then it changes back. I found out the time at which my body wakes up best, and it is what is in the fall called 6:15 a.m. That is when my body wants to wake up.
6:15?
6:15 a.m. If I wake up in the 7 o'clock hour, my body's all out of whack and I feel tired no matter when I went to sleep. But if I wake up between 6 and 6:30, usually right around 6:15, my body, I'm like up, there's like a pep in my step. I need less coffee. Like that is the time when my body is meant to wake up. But then daylight saving kicks in and I guess it's November, right? Yeah. And then that becomes 5:15, and that is too early for me to wake up.
Is it 5:15? No,
yeah,
it's
fall back.
If you wake up, at 5 in the morning, it's still dark and nothing's open.
I mean, I'd be fine with it. I'd be fine if it was.
If you sleep in later.
No, but what I'm saying is I'm tired then. All of winter.
No.
I'm tired.
No, it's the other way around. When daylight savings time comes, in the spring, which is like a week away.
Yeah.
Daylight savings time, it's going right up here. The clocks go forward, but because they go forward, we lose an hour and we're more tired. We're actually losing time.
That's not, I found out that my body wants to wake up at that specific time. So all of spring and summer, that's when my body is waking up when it's supposed to wake up, is what spring and summer 6:15 is. But then when daylight savings kicks in November, well, I guess it's back to normal, I guess is what it is.
Yeah.
So in November, when you fall back, that's when my body's like, no, because then it becomes 5:15.
You're a fighter. You never fall back. And springs spring back. When you compress a spring, it springs back. Springing forward, it makes no sense. It's just a horrible.
Well, better than falling forward, you knock out your teeth.
Concept.
I'm gonna be a mess for like a month after this daylight saving switch happens. It just doesn't work for me. No, it doesn't work for me. I lose an hour. It's dark again in the morning, and I'm like, ugh. And then when the sun starts rising, then I start rising with the sun. I'm better at it, but oh my gosh.
It's very silly. It needs to go. Why are they messing? It's, you know what? It's the Illuminati messing with our circadian rhythms so that everyone is sleepy so that they'll get complacent.
That's right. Keeping us in control.
Yeah.
The man.
They're just beating us down. Okay. Anyway, the newsletter. Yeah. Do we want to make just next time when you make the March run sheet? Do you want to
get it? Oh, what? Put it in the run sheet?
No, not put it in the run sheet, but just also you can whip up an additional
new tab
Excel or sheet document, because I don't know where those actually live. It lives on in your world somewhere, and then it's just shared with us. So that's something that you could create so that you own it, and then you share it with us, and we can just have tabs for the different issues, and we can put in the name of the tab, like we could put when we want to release it, and then we can plop in stuff into those sheets, and then it would be very easy for me to make them.
Okay, we should figure out how much we can each contribute, or what, or when.
Yeah. So, I mean, I feel like Justin writes disclaimers every week. I'm sure we could get some sort of musing from him. A weekly rant of sorts.
Sure.
Just a paragraph, just something short. Yeah. Just something science related.
Something that you thought about.
Yeah.
Justin's amusing thoughts.
Yes.
I can come up with 300 or 400.
Yeah, that's what I'm saying. Just think about something you want to write about that you'd want our loyal listeners and subscribers to our newsletter to know.
You can even make it a serial.
Yeah, that would be fun. Like issues.
Yeah, something that comes out over the course of several issues.
That would be very fun.
Sounds like people are trying to put work on my
plate. Creativity.
Just a paragraph.
That word, and it's not work. Then,
just like 1 to 2 paragraphs. Yeah.
Okay. Is it okay if it's all about how to retrofit a bus for a little while? And then it goes off into other subjects.
If it is science related, then yes.
Of course, there is a science to everything, including bus conversion.
If it is science related, I don't see why not, Kiki.
Yeah. I think people would like the occasional bus update.
So I do like
retrofitting a bus. Okay, what?
I do like the prompting idea of like there's a place for us to go and like attack something with words. It sounds good. Sounds like a decent outliney plan.
Oh, great.
Yeah. Feel any creative stuff.
Excellent. Sounds good. And break. Okay.
Let's see. Tell your friends, I guess they're in different cities. If you have friends in Portland, tell them about our show April 3rd.
Okay. Justin, hey, Kiki, there's a show in Portland.
Thanks. Justin, do you have plane tickets yet?
How would I get plane tickets?
Are you going to drive up here?
I have never booked a flight on my own.
Oh my.
Ever in the history of my existence.
So there's this thing called google.com. Type in www.google.com and type in Sacramento to Portland flights. And then something will pop up where you can put in your dates and it'll give you some options.
Okay.
I did it before, just face palmed.
I'm not even joking. Like I have flown crisscrossed around the country and the world, but I've never been the person who booked the flight or bought the ticket.
It sounds like it's time.
Ever.
Yeah. And Pam, this is exactly why Justin hasn't visited.
Yeah.
He's like, what?
High time.
Yeah. If you like, Pam, if you hit me with an email like your flight leaves at this time, you need to be at this airport by here, I will be there. I'll be on the flight. I just have no idea where plane tickets come from. It's kind of like babies and
so the stork goes to www.google.com and types in Sacramento to Portland flights, and then he puts in the dates and the times and compares the prices, and then he hits buy, and then he puts in some credit card information, prints those out, and then flies them to your door.
And Justin, I think you're now visiting Pam. No.
So, Kiki, I think this is a good time for us to bring up, should we start some sort of Kickstarter or specific campaign to do a TWIS Australia tour?
That would be amazing.
Yes, that's good.
Australia and New Zealand.
I would love to do that. I would love to do that. That'd be great. Yeah. Okay, let's think about that. Pam's like, yes.
It's something I've wanted to go to Australia since I was 9.
It's like, small continent.
Yeah.
It's
one of the smaller ones. It's fine.
I had evidence of my inabilities in the past. Blair, do you remember when I was overwhelmed looking at subway schedule maps
I do.
in New York? I would have just walked and everywhere and not gone on any sort of mass transit in New York because I didn't understand.
You would have gotten mugged for
sure. What the hell? The symbols and the lines.
Yeah, I feel like you would have gotten mugged.
What? Yeah. No, I'm the least muggable person.
That's not true. You're the one walking around pointing at things.
Look at all the tall buildings. Wow,
you're like, you said you wanted to go on a boat ride. I should walk up to this person that's shouting about free boat rides.
Is that hold up? Is that not where we got our boat ride?
Yeah, and they almost didn't accept our tickets, Justin. Remember that?
No, we were very, no. This is okay. No, what happened was Blair's like, look like you know where you're going.
Yeah.
And don't look anywhere. And so we walked like we were going because there's people who were looking for people who are tourists. And we walked right past them and headed down a dead end. And somebody's like, okay, it's obvious you don't know where you're going. So you must be looking for the Statue of Liberty. And we looked at each other and was like, okay, they got us. Like this.
Yeah.
And then we bought the tickets. And then the whole way, the 2-mile walk to where the ferry is, we were convinced the tickets were bogus and that we'd gotten taken.
Yeah.
And so Big City Girl, who's been my guide this whole time, is like, go up to the counter and find out if the
I don't want to look like I don't know what I'm doing.
No, I got this. I'm the Big City Girl. I have to know what I'm doing. But you don't because you're a country bumpkin. Go up to the counter and find out that these tickets are. And it turned out they were legit.
They were.
So we went on so we got to do the thing. So basically what we're saying is throw yourselves into the confidence of others without knowing whether or not that's the right thing. We're working out in our one.
Hey, I did a fine job navigating the subway and getting us to the top of the Empire State Building.
Would not have figured out how the elevator worked. There was too many buttons.
There were a lot of buttons. I found us some delicious deli food.
Whoa.
Huh?
Second F Deli was my idea, not yours.
Oh, that's true, but I found it.
That was mine.
But I found it.
Because it was on 3rd. That was weird. It was the 2nd Avenue Deli. It was on 3rd. Like, I don't know. Like, I kept walking up and down going like, doesn't exist. And you're like, look to your phone. And
if I do recall, the sentence I just said is, I found the delicious deli food.
Found it,
which
but
is what I did.
It.
Yeah,
I chose it.
Sure.
That was where I wanted to go.
There you go. Anyway, I am flying in Wednesday morning. I am landing at 11, just so you know.
Good.
I, on the other hand,
start walking.
That's right.
We'll be hitchhiking starting the Monday before the Wednesday show.
Good. At least you're planning ahead.
Hope to make it on the
2 days isn't enough.
Trust and confidence of strangers.
2 days? You can't hitchhike to Portland in 2 days.
Oh, you can do it in one. if you do it.
No, because nobody picks up hitchhikers anymore. You have to wait too
Actually,
long.
that stopped because nobody hitchhikes anymore. When you hitchhike, people are like, what is like? No, people don't know not to pick up hitchhikers
Oh
anymore.
my God.
Because it's been so long since picking up hitchhikers was a bad thing. And then-
I don't pick up hitchhikers.
I don't pick up
You
hitchhikers.
don't?
No.
No.
Oh, you should. They're the best.
No
people.
way.
They're the
No
best
way.
people to-
Nope.
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 Okay.
Nope.
Can I just tell you? Can I just
Buzzer
tell you?
here.
Can I just tell you? You're buzzing it, but you know who picks up hitchhikers constantly? Uber and Lyft. That's like all they do, and it's a huge business.
True.
Well, they're not sticking
Right.
out their thumb for those.
Say goodnight. That's the icon when you hit the thing. Say goodnight, Blair.
Good night, Blair. Say good night, Justin.
Good night, Justin.
Good
night, Kiki.
Good night, everyone. Check us out next week. We'll have a cool interview. Can't wait for that. And also this Friday, 1 p.m. Pacific time, twitch.tv/Dr. Kiki for my Dr. Kiki science talking, chatting time. And we're going to work on another newsletter. So make sure that you are subscribed. Good night, everyone. I hope you have a fabulous, fabulous science-y time.